11.4-ish, which we did with circles. In there we talk about circumference. We talked about circumference with a circle. And the reason that I want to bring this back up is because we actually use a little bit of this stuff in 11.5. A lot of it comes with some of the vocabulary, so I just want to make sure that you guys remember a few things from here and there from some of these few things. So circumference with circles is the perimeter, if you will. It's the distance around, okay? The circumference is the perimeter of a circle. It's the distance around. And it had a formula to find it. Yes, sir? Yeah. Very good. Circumference was equal to 2 pi r. We also wrote it one other way as well. What's that? Pi times the diameter. What's the other way we wrote it? Because twice the radius is always a diameter. So those were the two ways that we wrote out circumference back in last week-ish. Now, the other part of circumference stuff, let me write this out here so you have it. Is that we used circumference for dealing with what was called arc length. Now, arc length is a portion of the circumference. Arc length, if you recall, was part of the circumference. It was made up by so much of an angle, okay? So when we dealt with an arc length, and I'll redraw this picture. When we dealt with an arc length, that was the distance on a circle given by an angle. Okay. So it was a portion of the circumference. How much of that, bless you, how much of that portion? Well, that depended upon the angle that you were given. So how many degrees are in a circle? 360. So in order for us to do this, all we did was we wrote up the formula, arc length. It was your angle, your central angle, over 360, times the circumference, 2 pi r. Or we wrote it as angle over 360, pi times the diameter, or an angle over 360 times circumference. Remember how we wrote it out 3 different ways? Any one of them worked, just depending upon what information you had to start with and what information you were able to work with afterwards. So arc length, we also did a lot of this in terms of pi. We just pressed some buttons on the calculator, and it worked. And you left your answers in terms of pi. Now most of you guys still do that, but some of you guys still give me decimals. It's not the end of the world, but you don't have to worry about decimals. It's just an extra button. So let's see, we're doing arc length. Angle over 360, 2 pi r. Okay. So arc length was just a portion of the circumference. Circumference was the whole thing around. Well, today we talk about area of a circle and area of a sector. Well, area of a circle is all the stuff inside the circle, and the sector is just part of the circle. Very similar to circumference being all the way around, portion of it, whereas area is all the stuff inside, and the sector is just a wedge of it. So it kind of goes hand in hand with what we've done before. Now, this really isn't a lot of new stuff, because I'm going to go out on a limb and make a rather general assumption that you probably all know the formula for the area of a circle.
Base times height.
Get out of my room. No, really.
Okay.
I find the area of a circle. You guys know this. Come on. Every single one of you have used this before. This is not new.
I got a feeling when you said it. No.
Yeah, yeah, we got rained out for baseball, but other than that, it's fun.
Give us a hint.
There's something squared in it.
Oh, it's pi squared.
No.
No.
He's
Hey, pi times radius squared.
Yeah.
I thought that was
Ladies and gentlemen, you all knew that. Pi r squared. No, pi r round.
He's good.
So, quick little stupid story, because I never had any of those. When I graduated college, my parents decided it'd be kind of funny to, had dinner or whatever at their house and all. They made a dessert. They made a square pie.
That was good. I like that. Is that a joke?
No, it was true.
Oh.
Wait,
It
how?
was nice one though. Get it square pie.
Because I had a degree in math, and they thought it'd be funny to make a square pie.
Oh.
Yeah.
How cute. They're
Good.
They were, parents.
Mr. Murphy,
So, yes, sir.
you know they only have one drink size in North Korea?
What's that?
A Supreme Leader.
What flavor was it?
Yes, sir.
You think a sector is like a section.
Yep, and that's it. That's exactly what it is. The sector is the wedge of a circle. It's part of the circle. So if you have a sector would be this. So the sector in a circle is a portion of the circle. Okay. What's that?
You like right. When you're writing on the smartboard, it looks weird because your hand's like down here. So I don't know. Maybe I'm just.
So when we're dealing with sectors, what we're looking at is we're looking at portions of circles. And just like when we dealt with portions of circumference, when we're talking about portions of portion of areas, it's still going to be defined by some sort of a central angle. So a sector is defined by some angle, some central angle, and some radius, which means that the area of the sector is just going to be a portion of the area of the circle. That portion, again, is just defined by the angle. So the area of a sector is going to be the central angle, over 360 times pi r squared. Okay? So this area of a sector that portion, that wedge, whatever it might be, is just going to be whatever the central angle is over 360, that fractional amount, times the area of a circle. Okay. Which means, like we've done before, you know how arc length, we wrote it as 2 pi r, pi times diameter, and then we wrote it as just plain old circumference. One of the things that you will see from time to time is that you might have to work backwards to find the area of a circle or something like that. What does pi r squared stand for? Area of a circle. So one of the things we can do is we can also write it like this. Instead of just saying area of a sector is angle over 360 times pi r squared. Sometimes they write it as just times the area of the circle. Okay, and there's a reason why I wanted to write that out, because in a minute I'll show you guys what can happen algebraically and what we can do. Yes, sir.
So, the circumference to the arc length
Yeah.
is like the area of the circle to the area of the sector.
Yeah, exactly. That's what I was getting at, because circumference is the whole thing, the arc length is a portion. The area is the whole thing, the sector is a portion. So that portion is always defined by the angle. How much of the circle are you using? Okay. So this stuff actually works out really, really nice, and it's pretty quick. Let me see if I can make this work better with the lights out. I know you need to play. So red doesn't show very well.
That's cheese pizza.
Yeah. So let's do this. So we have a radius of 4 and an angle of 80. Let's find the area of that sector. A lot of these are just plain old shaded region. Okay? Shaded region can be defined by the central angle. Shaded region can be defined by the measure of the arc. Remember, the measure of the arc is the central angle. That comes up from time to time. So just like we've been doing, start by writing it out. These can all be written in terms of like an exact answer.
Okay, so it's.
See what I'm saying? And now I'll show you guys a couple of tricks to make sure you can be able to get to the exact answer. Now, when I go to type this into my calculator, I put pi last. I write out the formula with the pi in the middle because that's usually the way things are written. But then when we put it in terms of the calculator, we put it last. So it's going to be what? 80 over 360 times 4 squared pi. And if you type it in just like that, it'll spit out a clean answer for you.
Oh, but if you do it the other way too, you can still do it.
Okay, sometimes it doesn't though. Sometimes that if you put the pi in the middle, sometimes it gets messy. That's all. But if it does that, you give me a decimal, it's not
No, I didn't get it this way.
It was only
Yes. Okay. So what are you getting then?
39 pi.
What was it?
39 pi.
Something squared. Remember, this is area, so it's still something squared. Okay?
Oh, it is 32. I read that wrong.
Thank you. All right. Yeah, you're right. 'Cause if it was 39 pi over 9, we could have simplified that by 3 and gotten 13 pi over 3. So I should. Okay. Now, when we're doing these things, it is quite often really fast. It is formula work. There's not a lot of crazy stuff going on. We'll get to that eventually. Oh, sorry. Yes, sir.
Okay, so, well, you see, but, when I was doing it, I simplified 80 over
Yep.
360, and then I,
That's fine.
yeah, I almost squared 4, it was like pi 16.
Yeah.
What was the 2 over 9, like, and I kind of split like 1
Yeah.
over the.
That's fine. Perfectly fine. There's nothing wrong with that. Nothing wrong with that at all. And actually, you know, if you have your, if you just, I mean, if you have your phone right now, you can use that as a calculator and put that through and just put pi in the end. Because it'll still work. You're just going to give me a decimal. That's all. All right. So, let's try this. Now, this one, there's actually 2 questions. We're going to find the area of the 2 different sectors that are formed here. One sector is shaded, the other sector is not shaded. That's convenient when they do that. So if I want to find the area of the shaded region is a sector. Well, formula of the sector is, well, let's write it out. Area of the sector is angle over 360 times pi r squared. And then it's fill in the blanks. That's it. Okay? Fill in the blanks. 110, 360, 21 squared, and a pi.
I have.
Yes, sir.
I forgot why we flip the pi and the radius squared. Like, it's easier.
What do you mean?
Type in your calculator. Right?
Oh, put it last?
Yeah.
Oh, okay. When you're putting it in a formula, variables are last.
Okay.
When you put it in a statement, pi is a numerical representation, if you will.
Right.
that goes last because all the variables have been used up.
Oh, okay.
It's just math etiquette. Okay, you can say it's r squared times pi, but that just sounds weird.
Thank you.
When you put this all together, again, all you have to do really is just kind of type it in. So, fraction bar. So even if I didn't have my calculator and I had a phone or whatever, I could still do this at least. That gives me my fraction of 539 over 4. And I just have to slap a pi next to it. Yes, thank you, I almost forgot. This is a unit of squared, so it is whatever it was squared. Okay. Now, the other one, what would the central angle be for the non-shaded?
220. I mean, 250.
No, it's like 1040.
Oh, he told you the time?
Yeah.
It's 10:39.
To be specific.
Oh, you can still use the same.
To be specific.
What's that?
You can still use the same rate.
Okay,
Same circle, isn't it?
Thumbs up.
Because we're looking at the two sectors. Here's one of them.
Okay. So we take that minus, or 360 minus.
Yep. Yep. Okay. And you press some buttons, you're gonna get some crazy looking fraction again. Okay. It's not very, hopefully not too crazy. Whatever it works out to be. I didn't have a calculator on me. What did you guys get for this one? It's like 1,000 something, isn't it? That? Sorry, that's bad for. Okay. All right. Let's try another one. This next one, guys, come on. This next one's a little bit different. This next one's a little bit different, whereas this one is giving you the area of the sector. Find the area of the circle.
Oh, that's
Okay?
So are we looking for?
No, it's just asking for the circle. Now, let me show you this real fast. And I kind of was alluding to this earlier when I wrote it on the whiteboard. Now, we know that the area of a sector is angle over 360 times, so used to that arc length, pi r squared. Pi r squared stands for what? What is pi r squared? What is that? It's the area of a
circle. So
Okay.
you just times by the area of the circle.
So this is the same thing as saying times the area of a circle. Central angle over 360 times the area of a circle. Now, if I wanted to get area of a circle by itself, I would have to move this. That's just a fraction. How do you undo multiplying by a fraction? Multiply by its reciprocal. So what I'm doing ahead of time here is saying that if I take 360 over my angle times the area of a sector, it will always equal the area of a circle. Yes, sir? Yeah, and your answer is not 6, 7, 8, 9. It'd be funny if it was. So basically what you're looking at here is setting something up like this. Now, what we're doing here is before the math, we're isolating what we need to solve for. What we're doing is we're using what's called a literal equation. You guys have all done this before without even realizing you've done this. For example, you go back to this real quick. Pretty sure you guys have all worked with that formula. Distance equals rate times time before, correct? Now, if I wanted to get time by itself, how do you undo multiplying by the radius? By the rate, excuse me.
Divide.
Divide it. So you could say that distance divided by rate equals time.
Yeah.
Now, what I'm doing here is if I have a whole bunch of problems that I have to solve for just using distances and rates, I would set up my equation like that first, so that way I'm just reusing it all the time. Same goes with the idea of when we did that trig of an angle as a number over x or an x over a number, how we always knew which way we had to exchange-o, change-o, or multiply through. It was the same idea. We were setting up a general rule to use over and over again. So it might not be a bad idea to make sure that you have this written down also, in case you have to solve for an area of a circle, because it's one way that you can do it, okay? So now in this case, I could just fill in the blanks. Take my 360 over 70 times 123.45, and I get my answer. Okay? Instead of trying to put it all together at first and then move stuff around, move it around before you substitute in your values. Sometimes it's a lot easier to deal with. There's a lot going on sometimes with these. Okay? And that gets you how much? 634.81? 89. Thank you. Something meters squared.
We'll get
Okay.
it because 6 and then 3 plus 4 is 7 and 8.
Oh.
Quit while you're ahead.
But look though,
I know.
6 and then no. Yeah.
All right.
Yeah.
They knew what that is.
Yes.
Geoland. It's called. That's very true.
All right. Let's work backwards again. The area of a circle is 29 square feet, or 249 square feet. What's its diameter? The area of a circle is 249 square feet. What's its diameter? Okay. So if they're giving you the area of a circle, what formula do you think you should probably write down?
Wait, I forgot.
Angle over 360
Area
times
over area of a circle. Area of a circle is pi r squared.
So then you just
Put the stuff in. So we know that the area is 249 pi r squared. Now, this means we have to know how to press buttons on the calculator correctly. Now, I'm starting with that. I need to get the r stuff by itself, which means what do I do with the pi?
Divide it.
Divide it. Good. Divide it by pi. And that's going to equal r squared. Now, when you divide it by pi, 249 divided by pi, you're going to get some crummy decimal. This crummy decimal equals your r squared. What do you do to that to get r by itself? How do you undo
Square
square
root.
root? You square root. So this gets us to the point now where we have to make sure that we know how to press the right buttons in our calculator to be able to do this. So since I just pressed enter, that means that this 79 and change is my last answer that's stored.
Second root. Second answer.
Yep, exactly. Second root of my answer and hit enter. That gives me a radius of 8.90.
But that's not the diameter, so you do it twice.
Right. That's where you're getting to that as well. Now this is now my radius, which means what do I do to that to get the diameter?
Times it by 2.
Or I can add it to itself, or I can just do this real fast. And there's my diameter. 1781. Okay? That gives me my diameter. Now that's by just using straight calculator. I didn't have to write down and round off all these numbers each time I'm pressing enter to go through it, because the calculator will store these values for you. Yes, ma'am.
What if we don't put the one, like what if we just say
A lot of times I go 2 decimals. So that's why I say round to the nearest 100. So that means go 2 decimals.
questions?
Yes, ma'am.
Oh,
Oop.
Can you both go back so I can see your work?
oh yeah.
Go back
Go back where?
so I can see the work.
Oh, sorry.
Yeah, you're good.
This? Yes, sir.
So if you round this to the decimal
Right, and it just depends on how you set it up. I mean, more often, if you just leave it all in the calculator and then write down your answer at the end, you'll have less rounding error. That's what this is. We're alleviating the pain there. So, Leon, what exactly we're looking for?
Like, take away that screenshot. 'Cause you did the work.
Okay. Now remember, it is nothing more than quite literally a bunch of buttons that you're pressing. But you have to know the right way to set them up, and you have to push them in the right sequence, otherwise you're just going to be pressing buttons. Okay. Yes, ma'am. I got you. Well, no, I know. There's how much money? There's not one on here.
You shouldn't say you
They know.
There's not one around. Give me one. Give me 1 second. I'll take care of it. Okay.
Okay.
All right. See how we're doing. So we have angle over 360 times pi r squared. So we have 60 over 360 times 10 squared pi, which is 100, 1/6, 50 pi over 3, something squared. Okay. Then the other one, again, it's just a matter of figuring out what the angle is. Well, you've got three congruent tick marks. If you know how many degrees are in a circle, which I hope that you do by now, you wind up with 120 as your central angle. So 120, 360, 24 squared, and a pi. 1/3, 576, so this would be 192.
No.
How we?
192 square feet, pi square feet.
Yeah.
Yes.
Wait, what were you doing in your head?
When I did that? Well, I know 120 and 360 is a third because there's three congruent spots, so that's 1/3. 24 squared is 576. 576 divided by 3. Well, remember shortcut division?
Yeah.
3 goes into 5 how many times? 1. How many are left over?
2.
27 is 9 with 2. Shortcut division. Shortcut division is one of the greatest things you guys probably were never taught.
No.
Okay? It comes in really, really helpful in algebra
We
2.
were taught like the long way.
Yeah.
You can do long division with this too. Long division, we actually do, we do long division a little bit in algebra 2 with polynomials, but we show you guys a much easier way with what's called synthetic division. And it looks really, really weird, but it is extremely efficient in finding zeros in polynomials. I wish we should show you guys that in algebra 1. It would help you learn how to factor better. You're just like, I mean, politely.
Yeah,
I zoned out. Like,
Yeah, I could tell.
me too.
A lot of things in my head right now. Sorry.
All right, so let's try these two. Again, these are the styles of ones where you have to work backwards, okay? Now, what I'm looking at here is we're going to find the area of a circle, and we're also going to try to find a radius of a circle. So there's two different things we have to do, but we're given areas of sectors to start with, okay? So in the first one, you have that area of a sector at 3952 and a central angle of 175. Now, we've already written out the formula for area of a sector versus the area of a circle. That one's relatively easy to set up. This up just a bit. So area of a sector. So we had that generic to start with. Area of a sector, portion of the circle. Remember, just multiply by that reciprocal.
The area is 39.52.
And you just put it together. Okay? So here you're gonna get, what is that, 360 over 175 times 3952.
I did. Calculate the
And times 3952. And you get 81.3 when you round out the two decimal places. Be okay with that?
Yeah.
What's wrong? You're staring at that like I'm crazy. You have this cross-eye
Are
going
you
on.
talking to me?
Yeah, you're kind of looking at it all.
I'm just confused because I want you like I'm trying to figure out what you did when you like the last part.
Which part? When I flip this over here?
360 divided by 175.
Yeah.
And then what did you do after that?
Oh, I pressed enter.
Well, I
Well, you asked what I did. All right, so what I did there, I didn't put it all together as a string. If I did it the other way, I would have done it like this. I would have made my fraction 360 over, what was it, 175? And then hit times 39. What I did was I just did it on a different sequence. I didn't make my fraction bar because on this calculator it's so many more buttons I have to press that I didn't want to, so I was being lazy. So what I did was I let the calculator do the work. It gave me a decimal equivalent. I hit times what was left over. That's all. Okay. So that gets me that one. Now, what's going to change differently then for the next one is that it's asking me to find the radius of this circle. Okay? It's asking you to find the radius of that circle given the area of the sector and the central angle of the non-shaded region. Okay? So if you have to find the central angle of the shaded region, what would you do? Subtract it from 360. Very good. So start with that. We know that the non-shaded is 78, which gives me a central angle going this way of how much? Oh, do the math. 360 minus 78. Okay, so there's my angle. Now, again, knowing how to set this up, we have 360 over our angle of 282 times the area of the sector, which is 20.89, is going to equal pi r squared. Now, the reason why I'm writing it out as pi r squared is because eventually I'm going to have to find the radius. So I need to get some decimal equivalents to start with. So I start with typing in the calculator the 360 over 289. 360 over 282. And then I multiply that by 20.89. This crummy number equals pi r squared. What do I do to that number to move the pi? Divide it by pi. So now, right in my calculator, I hit divide by pi. This now gives me r squared. What do I do to that now to get r? Square root it. So second root of your answer, and hit enter. And your radius is 291. Okay? It's nothing that's difficult. You just have to know how to press a button. This is really pure formulaic work for today. All right? There's nothing. I'm not going to have any time to get into the extra shaded region stuff that we'll get to tomorrow. All right? Yes, sir.
So if it add,
Hold on.
I was confused. Aren't you supposed to? You already squared it, right?
Yeah, I had the original problem. I had it at 26.668.
Then you all divided by 5.
Here. Here, this might be helpful. So this equaled pi r squared. I divided this by pi, and this equaled r squared. Then I square rooted this, and then this equaled r. That's what I was doing in that sequential order. Does that help? Problems I have for you tonight is 11.5. I forgot what page it is. I gotta go grab the book.
I can see that one. What? You looking at your earlobe?
Seven through 16. And if you give me a second, I will load this up so you can get a picture of it so you can get started.
Mr. Murphy.
Yes, sir.
You know people in Dubai